Thank you everyone for attending lesson one, and now we are on to lesson two of the pre-calculus slash trigonometry course, properties of functions. Today we're going to be going over the things like domain, range, x and y intercepts, and even and odd functions, all things we need to know before going to pre-calculus and especially calculus. So the first thing we're going to introduce is domain. Domain is all the possible x values that there can be for a function. This is the opposite of the range, which is going to be all the y values. Now, first, let's focus on the domain. The domain, here's how you find it. The domain is negative infinity, comma, positive infinity. If you remember, this is called interval notation. The parentheses mean you don't include infinity versus a square bracket, which means you include infinity. You may be wondering, why don't you include infinity? It's because physically you cannot include infinity. It's an abstract concept. Basically, what I'm trying to say is it always gets parentheses for this interval notation, which is what we're going to be focusing on today. But I also want to say that the domain is everywhere. That's what negative infinity to positive infinity means. The domain is everywhere, except for domain errors. Now, there's 4 domain errors we need to know about for pre-calculus. Honestly, there's a lot more than 4, but there's only 4 you will ever see in pre-calculus. It's the 4 I have listed right here for domain errors. And honestly, for today, we're going to only be focusing on 2 of these because the last 2, logarithms and inverse trig functions, that's going to be probably covered in a later lesson. So first, 0 in denominator. This is pretty straightforward. This is things like 2 over 0, or for instance, 2 over x at x equals 0. You can't have a 0 in the denominator. What's that called? Undefined. So yeah, we cannot have 0 in the denominator. Another thing we can't have is the square root of a negative number. This is examples such as the square root of negative 2. You can't have that. Now, most of the time, they don't give you square roots of negative numbers, right? They're going to give you a square root of, let's say, x. I'll even make it more complicated. Let's say it's the square root of x plus 1. Slightly more complicated, not that bad overall. So what do you do for square roots of negative numbers or square roots of functions? You need the thing in parentheses to be greater than 0, greater than or equal to technically. So what I mean by that is if I say x plus 1, the thing in the square root, is greater than or equal to 0, then we're good. We're good for our domain. If you subtract 1 from each side, x is greater than or equal to negative 1. Now you see why we focused on inequalities last week, right? So x is greater than or equal to negative 1. That would be the answer for the example I just made up. In other words, if you plug in negative 1 to square root of x plus 1, you're still good. You get the square root of 0. Many kids say square root of 0, that's undefined. And I say, no, it's 0. Your calculator will agree with me. If you plug in negative 1.1 or negative 1.0001, now you're outside of your domain. You're going to crash the function. Your calculator will say error. So that's what we do for negative square roots. These are the only 2 examples we're going to look at today, but I am going to just tell you the last 2, just so you know. So logarithms, I'm not even sure if you know what a log is. You probably covered it in algebra 2, but maybe you don't remember. These are functions like this. Basically, you can't have log of negative 1. You also cannot have log of 0. Both of these will break the function entirely. And again, these are domain errors. They cannot be true, what I just wrote. And then the last example is an inverse trig function, which is honestly too advanced for us today at all because we're not on trig functions until like lesson 5, I think. So we're just going to actually skip that one entirely. But you're going to see it eventually in this class, probably closer to the end of the year. And now the range is all the possible y values of the function. Basically, domain errors, there's an easy way to find it. You just plug in the values for x, you're good. For range, look at graph. That's the easiest, and right now, not the only way to find it, but definitely the only way I'm going to ask you to find it. And by the way, I'm just going to tell you now for the homework so there's no confusion. As you're doing the homework, I'm going to let you use a graphing calculator to actually graph the function so you see what they look like. You can also graph them on something like online, like if you Google Desmos graphing calculator, spelled D-E-S-M-O-S, like this. If you type in Desmos graphing calculator, you have a free graphing calculator. You can graph any function you want. I'm going to let you use a graphing calculator to at least get the graphs, but I do want you to find all the answers by hand. And I'll explain that more by the end of the lesson. So here's some examples where we're going to find domain and range. The first one is x squared. Think about it this way. You look at the function negative infinity to positive infinity for the x values. There's no value for x that's going to break the function. I repeat, no value for x that you can plug into x squared that's going to break this function. Let me prove it. If you plug in 5, 5 squared is 25. If you plug in negative 1,000, well, negative 1,000 squared, you can plug that in your calculator. You get a result of 6 zeros, positive 1, 1, 2, 3, 4, 5, 6. Yeah, it's 1 million. So no matter what value you plug in, you're going to get an answer at the end. What I'm trying to say is the domain is from negative infinity to positive infinity. And the way you can tell that on the graph is because if you look at the graph, this thing's just going to explode to positive infinity on both sides, which is exactly what it does. Now for the range, looking at the y values. The easiest way to do range, just say lowest number, comma, highest number. So the lowest number looks like right here, 0. So 0. Do I include 0? That's actually a question for the audience. Can someone tell me, do I include 0? Yes or no?
Yes.
Yes, we do. Why? Because if you plug in 0 for x, which is what that point is right there, you plug in 0 for x squared, well, what's 0 squared? It's 0. You include 0. When would you not include 0? That's going to be for asymptotes. I think we're going to cover that also today. So we'll talk about it at the end. Now, the highest value you can have, kind of a trick question. It's not 5, it's not 6. The graph goes on forever. The answer is positive infinity. And since you can't include positive infinity, that gets a parenthesis. And since we said you do include 0, it gets a square bracket. That's the square bracket. That means include 0. And so there's our domain and there's our range. Any questions with that first one? Okay, great. It only gets harder from here, folks. Okay, next. X cubed minus 4x. Same thing, you can either look at the graph or you can think of the domain errors. Right now, I still don't have a square root. I don't have a 0 in the denominator. I don't have a logarithm. I don't have trig functions or inverse trig functions. So in other words, the domain is once again negative infinity to positive infinity because there's no domain errors. That's my reasoning. Again, domain errors are those 4 reasons I said earlier. Now for the range. Again, I just have to ask myself, what's the lowest point and what's the highest point? For anyone who says this is the lowest point and this is the highest point, I would like to challenge you on that. Why? Because the graph, let me erase this just so you can see it better, because technically the graph is going down forever. You're going down to negative infinity. And then on the right side, the highest point, again, is going up towards positive infinity. What I'm trying to say here is the range is from negative infinity to positive infinity as well. So negative infinity to positive infinity for both domain and range. Any questions on that one? Okay, excellent. We're now on to the next topic of discussion, the x and the y intercept. Basically, easiest way to explain it, an x-intercept is where the function crosses the x-axis. The confusing thing about the x-intercept is that this is where you set y equal to 0 and solve. Y equals 0 and solve. That's how you find the x-intercept. I'm going to be repeating this on blast for the next hour, so you're going to get it by the end. And then the y-intercept is where you cross the y-axis, and again, it's the opposite of what you'd expect. You set x equal to 0 and solve. And that's how you're going to find the x and y intercepts. So now let's look at some examples. For f of x equals x squared, we want to find the x and y intercepts. Now, first of all, with the graph, you don't even need to do this strategy. Why? Because the x-intercept is where it crosses the x-axis, which I'm just going to highlight the x-axis in blue here, okay? And if I ask you, where does the graph touch the blue line, the x-intercept, you'd say, oh, it touches it at 0, and you'd be correct. So we would say x-intercept, and I'm not going to say at x equals 0, I'm going to give the coordinate point. The x-intercept is at 0, 0. It's the origin. That's where it touches it. Now, if I want to know the y-intercept, let me highlight that in red. The y-intercept being right here. Well, it looks like the exact same thing. It looks like it touches it at 0. This is a very unusual case where it's both 0 for both, but that's what it is. Y-intercept at 0, x-intercept at 0. Now, I'm sure now you're wondering, well, how would I find this if I didn't have the graph? This is where you do the strategy I just said. So for the x-intercept, that's where you set y equal to 0. If you remember, the function is f of x equals x squared. So what I'm saying is 0 equals x squared. We need to solve for x. Take the square root of both sides. Technically, that's plus or minus, but since 0 is still 0, x equals 0 is the answer. But remember, you got to write it as the coordinate point, 0, comma 0. And how do I know the y? Like, I know this 0, the first 0 is x. I know that's 0 because we said so right here. How do I know the second 0 is really a 0? Because didn't we say that right here? Y is 0? Yeah. So x and y are both 0. Not always that easy. The next example will be a proof of that. But I'm gonna fill it in here, 0, comma 0 for x-intercept. Now for the y-intercept. Y-intercept, that's where x equals 0. So for that, I need to say y, you can say f of x, doesn't matter, but I'll say y equals 0 squared, like y equals x squared. I mean, 0 squared is still 0, so you get y equals 0. And again, same thing, the coordinate point 0, comma 0. There's our answer. Any questions? We did it 2 ways, this problem. Very nice. Okay, now for the next one, I don't know what number this is anymore, but the other one, we have f of x equals x cubed minus 4x. If I ask you again, what's the x and y intercept? You can either use the graph, you can use the function, you can look at the graph and then check your answer with the function or vice versa. But either way, where does the function cross my blue line, which is the x-axis? It looks like here, here, and here. -2, 0, and +2. I'm not going to write that answer quite just yet. You can if you want, but I want to actually prove it with the method the hard way, basically. And then for the y-intercept, again, the red line being the y-axis, well, it looks like it crosses here at 0 as well. Again, we have the origin being on the x and y-intercept. Very rare, if I'm being honest. So now let's find the x-intercept for this one. I'm just going to write it on a separate sheet of paper. So we've got x cubed minus 4x, specifically f of x. If you want, you can change f of x to y. It doesn't matter. It's the same thing. So here's our function. If you want the x-intercept, then remember, that's where you set y equal to 0. So that means 0 equals x cubed minus 4x. And now we solve. Most pre-calculus students do not know how to solve this. It's a crying shame. I blame the state education system. But that's not the problem. The problem is you need to factor out an x. So if you factor out the x here, what goes into parentheses? Well, remember, factoring out an x, the same thing as like dividing both of these guys by x. So you're left with x squared minus 4. 0 equals x times x squared minus 4. You now set both of them individually equal to 0 and solve. First solution, x equals 0, that one's obvious. X equals 0 is one solution. X squared minus 4, there's 2 ways you can solve it. It doesn't matter. The way I'll do it today, I'll factor this. X squared minus 4 is x plus 2, x minus 2 equals 0. So that means you get the solutions -2, comma +2 as our answer. And of course, I want the answer for x-intercept as a coordinate point. So that means my 3 answers, like I said, are 0, comma 0, -2, comma 0, and +2, comma 0. Again, how do I know the y position 0 for all 3 of these? Because I said it right here. I said, for solving for the x-intercept, set y equal to 0. So that's why. This makes perfect sense. And again, these are my x-intercepts. And that also is true. If I look back at the graph, that's exactly what I said earlier. I said -2, 0, and +2. So that's good. And now if I want to find the y-intercept, hopefully you have more room than I do. If you want to find the y-intercept, x equals 0. So what that means is you're going to say y equals 0 cubed minus 4 times 0. Well, that's just 0. So the coordinate point is 0 for x, 0 for y. There's your answer for the y-intercept. Any questions? Okay, hopefully you're all pros at this by now, or at least you're really good at watching me do it, which is good enough for right now. Okay, now we're going to talk about even and odd functions. Probably the hardest thing we're going to talk about today, because it's kind of confusing, if I'm being perfectly honest. So the first thing, there's 2 things we need to know about even and odd functions. We'll start with even. The first thing about an even function is the formula. The formula is f of negative x equals f of x. What does that mean? I'll explain it in a few example problems. But the other important thing you need to know is that an even function has y-axis symmetry. What does that look like? Let me show you on the little graph right here. So again, here's the y-axis right here. If you have y-axis symmetry, then you have a function that, for instance, looks like this. Doesn't have to look like this, but it has to have y-axis symmetry. If you fold this graph in half like a hot dog, you're going to get a perfect match on the other side. So that's what y-axis symmetry looks like. And then for an odd function, what you need to do for the formula is you need to set f of negative x equal to negative f of x. Again, this sounds very confusing. I'm going to show it's actually not that bad. But it has origin symmetry. Origin symmetry just means you flip along x and y axis. You do both. Let me show you an example of this. Let me first show you a function. Okay. So here's the function. This does have origin symmetry. Looks like this. This is not the only function in the world with origin symmetry. This is just one of many. How do I know this has origin symmetry? Well, let me show you. I have the advantage. I have colored pencils. If you don't, you can just rewatch the recording and you can see what I'm doing. But first, I'm going to flip along the y-axis like a hamburger, or I guess hot dog, doesn't matter. But if I flip along the y-axis, your graph is going to look like this in red. Almost looks like a DNA strand. And then if I flip that then along the x-axis and flip everything like up and down, then I'm going to get the green, which you'll notice is exactly on top of the blue. And that's why it's origin symmetry. You get back to the original if you flip along the x and the y-axis. So the good news is, do you have to do what I just did on a test? Probably not. That's very rare. Is it important that you look at a function and be able to figure it out if it has origin symmetry? That's the more important part. And even more important is the actual formulas, which we have not even used yet. I'm talking about the things I boxed here. That's even more important. So we're going to do a bunch of examples today with that. First example, x squared, even or odd. Maybe you can tell from the graph what it is. Don't say it out loud. I'm going to show you what you do for the formal way of doing it, the long way, the hard way, whatever you want to call it. So it is a step process. Step one, you're going to tell me f of negative x. Here's how you do it. All you do is you say f of x, that was x squared, right? If you have f of negative x, you replace every x with negative x. And watch this. I put it in parentheses because you need to, negative x, and then that's squared. If you're playing like a Where's Waldo right now, or not Where's Waldo, but like a spot the difference game, you would say the only difference between f of x and f of negative x is the fact that I have the negative sign before you square it. And that's the most important part. It's before you square it. Now, I want to reduce this. How would I reduce this? Well, if I square a negative number, doesn't that make it positive again? Yes. So in other words, f of negative x equals x squared. In other words, they're equal to each other. You're saying f of x equals f of negative x, and because of that, it's an even function. Done. It's even. In other words, look at the graph. This is y-axis symmetry. Y-axis symmetry. Great. Now you'll notice I said it was a multi-step process and I only did step one. Yeah, I got lucky. I got to stop at step one because it was even. If it's not even, you got to go to step two, and if it's not odd either, you got to go to step three. You know what I mean? So we got lucky here. Because it was even, you only needed one step. Now for the next example, f of x equals x cubed minus 4x. So for this one, even or odd, again, I'm doing the same thing. Step one, f of negative x equals, and again, f of x, the original function was x cubed minus 4x. I got to replace every x with a negative x in parentheses, like this. See that, everyone? Negative x cubed minus 4 times negative x. Now here's the most important part. Remember, if you have an odd power, like x cubed, x to the 5th, x to the 7th, and you cube it, 5th it, 7th it, it's going to keep the negative. I repeat, it's going to keep the negative. That means we do have negative x cubed here. And of course, if you have an even number, 2, 4, 6, 8, that's going to get rid of the negative sign, like we saw on the left. Okay, negative 4 times negative x, that will be plus 4x now. And as you can obviously see, these two things are not equal to each other. which means it's not even. It's not an even function. That's fine. It just means we go to step two. Step two is you got to tell me what negative f of x is to prove if it's odd. Here's the easiest way to do negative f of x. First, just rewrite f of x. It was x cubed minus 4x. Then put it in parentheses and put a negative sign out in front. Now look what happens when I distribute the negative sign to both terms. I get negative x cubed, and then the double negative on the 4x becomes positive 4x. Look at that. F of negative x right here from step one equals negative f of x. The two are equal to each other. And because they're equal to each other, in other words, f of negative x equals negative f of x, because this is true right here, we would say the function is odd. For this one, you needed two steps. Honestly, there is no real third step. The third step is if it's not even and if it's not odd, then it's neither, and you literally would just write neither. So that's not a big deal. But any questions so far? Okay. Now let's go on and do some practice problems. So I'm not going to lie, you're going to be writing a lot for all of these. I did it earlier, so I know I can fit it in here, but just so you know, this is a lot, so write small. Because we're going to find the domain, the range, the x and y intercepts, and state if it's even, odd, or neither. So we're going to start with the domain. First thing I do for domain, do we have any domain errors with x squared minus 4? Do we have a 0 in the denominator? Do we have a negative square root? And the answer is no for any of those. No domain errors. Great. So then you immediately write the answer is negative infinity, comma, positive infinity, and you're done. So that's the domain. Next is the x-intercepts. If you remember the x-intercepts, that's where you say y is 0, right? So for the x-intercepts, 0 equals x squared minus 4. You can just add 4 to both sides, so 4 equals x squared. Take the square root, you get x equals 2. Wrong. Of course, you guys forgot to do the plus or minus. Terrible. Can't be doing that. You get x equals plus or minus 2. But remember, I want a coordinate point here. So I'm actually going to write 2 comma 0 and negative 2 comma 0. Because remember, the y value is 0, the x values are solutions. So that's it for the x-intercept. I'd recommend trying to fit the y-intercept beneath this. I do not have room, so I'm just going to write it here. For the y-intercept, that's where x equals 0. So for the y-intercept, all you're going to say is, you're going to say y equals 0 squared minus 4. 0 squared, still 0. So y equals negative 4. The solution is 0 comma negative 4 for your y-intercept. Okay, so we got through the easy ones. Pretty harmless. You'll notice I skipped two things. The first thing I skipped was the range. The second thing I skipped, well, I didn't skip it, but we didn't do even or odd either. Why did I skip range? Because if you want range, you need a graph of the function. I'm going to be doing that last because it's the least important out of all of these. And again, I'm letting you use a graphing calculator so you can tell me the range based on the graph. But back to this, let's find even and odd first. So remember the steps for even or odd. First thing I'm going to do, I'm going to say f of negative x. And by the way, let's say you think, hey, I want to skip step one because I think it's odd. Okay? Bad news. You don't skip step one. Why? Because step one, you find f of negative x. Do you know what you need for odd? You need both. You need this and you need this. You know what I mean? You need both of these guys. So you can never skip step one. So basically, the first thing you're doing is finding f of negative x. If it matches, perfect, it's even. If not, you check if it's odd. So anyways, for negative x, remember it was x squared minus 4. This is going to be negative x squared minus 4. I don't need to make the 4 positive or double negative or anything because there's no x there. I only have to change my x's. Okay, so negative x squared but does become positive, so you get x squared minus 4. Hey, this is great. F of negative x equals f of x. Fantastic. You're an even function. And then the last thing we're going to do is we're going to graph it and then find the range. You don't actually have to draw the graph on the homework, the problem set, but I'm going to do it right now at least to show you what it looks like. So the function x squared minus 4 is a parabola that opens upwards with a vertex of 0, comma, -4. Remember that range is the highest point and then the lowest point. The lowest point here is -4 in the y direction. So -4 is the lowest. The highest point, you're going up to positive infinity. Hopefully you can see that on both sides, definitely. So then the highest number is infinity. Infinity always gets parentheses. And -4 is included because you're touching -4. If there was an open circle or a horizontal asymptote, then you'd get a parenthesis. But we don't have that, and that's pretty rare, honestly. Any questions on number 1 here? That's it for this one. Okay, we are cruising along. We've got 3 more examples to go, and then we get to look at asymptotes. So a lot more good stuff coming your way. Number 2, y equals 1 over x. Again, we're going to find the domain first. Basically the same thing as the last one. Now, this time, we do have a domain error. When does the denominator equal 0? Well, set denominator equal to 0. So that just means x equals 0. And remember, that's not the answer. That's where the graph doesn't exist. Does not exist. So what does that mean? It means that when I write my domain, and this is the first example we've had this, but my domain is going to be negative infinity to 0, parenthesis, you don't include 0, union symbol, which if you've never seen the union symbol, it just looks like a U. It means you combine it with the next part. The next part is 0, comma, infinity, all in parentheses because you don't want to include 0. By the way, another way you could write this is technically x does not equal 0. This is fine sometimes, depends if your teacher lets you do it or not, but I promise you, you're going to want to know interval notation. This is called interval notation. Super, super important to know how to write that. Any questions on domain or interval notation? Okay, fantastic. Range we're going to skip at the end. Next is the x-intercept. So for the x-intercept, again, that's where y equals 0. You would say 0 equals 1 over x, and now you need to solve for x. Yeah, good luck with that, because the only thing you can do realistically is you can multiply both sides by x to get it out of the denominator. So you've got 0 times x equals 1. Anything times 0 is 0. So you get 0 equals 1, which isn't true. So in other words, there's no x-intercepts, and that's fine. That's a-okay with me, because it's right. Any questions with x-intercepts? Okay, next is the y-intercept. Y-intercept, I think I can fit here. So for the y-intercept, this is when x equals 0. So y equals 1 over 0. Uh-oh, bad. So there's no y-intercepts either, it looks like. Again, perfectly fine. This is great news for us. Let's work, right? So no x-intercepts, no y-intercepts. What does that mean that the graph looks like? Funny you should ask. Actually, I jumped the gun. Next is even or odd. Then I graph it. Okay, so for even or odd, I'm going to do it on a separate sheet of paper so I have more room. So for even or odd, first thing I do is f of negative x, which just means replace all my x's with negative x's, so it's 1 over negative x. Obviously, this does not equal the original function, which was 1 over x. So that was step 1, didn't work. Step 2 is I find negative f of x, which literally just means taking 1 over x and you stick a negative sign out in front. Now here's the question. Does 1 over negative x equal negative 1 over x? Are they equal to each other? And the answer is yes, because the negative sign location does not matter. You can put it in the denominator, you can put it in the numerator. It does not matter. So because these are equal to each other, we would say it's an odd function, which means it has origin symmetry, but I'm not even going to mention that right now because it doesn't matter. The question wasn't asking for symmetry. The question was asking for even, odd, or neither. Okay, next we are going to graph it so we can find the range. And again, if I plug this in a graphing calculator, you'll get a graph that looks like this, probably. You'll also notice that you have vertical and horizontal asymptotes at 0. And the reason why I mention asymptotes is because that's literally what we're going to be talking about next. We're going to be talking about how to find these asymptotes. But since we haven't talked about it yet, what this basically means is that the graph is getting closer and closer and closer to 0 the x-axis and the y-axis, but never actually touches it. So that last part I just said is the most important part. Never actually touches it. What does that mean? You're never touching the x-axis. You're never touching the y-axis. That's why there's no x or y intercepts. But it does have a range because there's a lot of y values we have here. As a matter of fact, I think this goes to negative infinity. This goes to positive infinity. So it looks like it's all y values except 0. Now, how would I write that in interval notation? Don't say it out loud. Just think about it to yourself for a few seconds. How would I write this in interval notation? And the answer is open parenthesis, negative infinity, comma 0, close parenthesis, union, open parenthesis 0, comma infinity, close parenthesis. There's your range. Any questions with that one? Okay, excellent. Next is number 3. I'm going to say number 3 is kind of unfair because I don't think any of you know what this graph looks like. Actually, I'm going to ask the audience, does anyone know what this graph looks like? Like, I know you know what sine is, you know, from geometry, SOHCAHTOA, opposite over, hypotenuse. But does anyone here know what the graph looks like, actually? Yeah, so this one's kind of unfair. But the reason why I want to look at it was because basically you can split up pre-calc into 2 parts. The part before you get to trig, which is sine, cosine, tangent, and then the part after you get to trig. And this is definitely the after part. You're going to probably do this in the second half of the year. But it's literally going to be half the year you're going to be spending on sine, cosine, tangent, and all their cousins and related family members. You're going to love it. Yeah, I'm sure that was convincing. So anyways, let's just get started with this. I want to tell you that for the graph, let me just show you what the graph looks like, because I think that's a good place to start. Because none of you have ever seen this before. So the graph looks like this. It looks like a squiggly line. I messed up. It looks like a squiggly line that has to go through the origin like that. Has to go through like that. And what do I mean by that? See how it's going up at the origin? That's what it has to look like. Technically, this goes on forever. It's a squiggly line that goes on forever in both ways. Goes on forever. And that means a couple things. Like, for instance, it means that the domain, if your domain is all your x values, and this goes on forever, it's all x values, negative infinity to positive infinity. And that's awesome, because that's an easy domain. Now the range, I don't know why I gave you 2 sine x, but basically, if you have y equals 2 sine x, it goes on forever, and it means that the highest point is positive 2 and the lowest point is negative 2. So therefore your range, since it's your y values, is negative 2 to positive 2. Why did I put square brackets? Because I am touching negative 2 and positive 2. It's not an asymptote, it's not a hole in the graph. You're touching 2 and negative 2. So domain and range are the easy ones for this one. What's harder is the x and y intercepts. So I'm not even going to do x and y intercepts the hard way. I'm not going to find them using x equals 0, y equals 0. Just looking at the graph, I see the y-intercept. The y-intercept is literally 0, comma 0. Why? Because look at it right there. There's your y-intercept. That's where you cross the y-axis. And then for the x-intercept, well, there's infinitely many. Let me prove it. I'll draw them all in red. Here's an x-intercept, 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 here's an x-intercept. And as much as I love saying here's an x-intercept, I don't feel like doing this for the next half an hour. So what I'm trying to say is for the x-intercept, what would you write? You can write a couple things, but I'm going to tell you to write, if you ever see this, I want you to write infinitely many. You remember writing infinitely many solutions back in Algebra 1 and Algebra 2? Well, yeah, there's infinitely many x-intercepts now. The good news is I didn't put any of these on the homework. At least I don't think I did. If I did, you can skip them. I give you permission because it's just too advanced right now. And I'm not even going to talk about even or odd because it'd be too difficult. But in case you're curious, it is an odd function. And if you want to try and prove that on your own by flipping along the x and the y-axis, I encourage you to do so. Again, this problem's too advanced, so I don't want to explain why. Especially for the couple people who just joined. Yeah, good luck figuring that one out. But for the people who did join late, the good news is that we have one more problem to go on the things we just spent the first half hour talking about. And then the last few problems, it's you're going to be on a blank slate because it's a new topic. So anyways, the last example we have, this is a more fair one. It's the square root of 3x minus 2. Ah, finally, a square root problem. That means you got to watch out for the domain because you cannot have a negative square root. So all that means is for the domain, you're saying 3x minus 2, the thing under the square root, must be greater than or equal to 0. And again, that's why we spent the first lesson talking about inequalities. You add 2 to both sides, divide by 3. X is greater than or equal to 2/3. How would I write that as an interval notation? I would say the lowest point you can have is 2/3, and the highest point you can have is infinity. Infinity always gets parentheses, and the 2/3 would get a square bracket because I said less than or I'm sorry, I said greater than or equal to, so I do include it. So that's it for the domain. Next, I skip range because I don't have the graph yet, blah, blah, blah. X-intercept, that's where y equals 0. So if I set y equal to 0, I know it's g of x, but it's the same thing. 0 equals the square root of 3x minus 2. How do I solve for x? First step, square both sides. So 0 equals 3x minus 2. Add 2 to both sides, 3x equals 2. And then x equals 2/3. Now, technically here, you're supposed to check for extraneous solutions. However, I'm just going to tell you, you don't need to do that when it's equal to 0. And I don't have a good reason for why, but basically, it's because I got one answer, and because if you really want to check, if you don't believe me, you plug in 2/3 right now, I promise you you're getting 0. Okay? I'm just trying to speed things along because this is a long lesson. Anyways, the x-intercept is 2/3 comma 0. Now you may be wondering, but Dan, why'd you put parentheses? I thought square brackets. I thought you're including the point. And then I say, no, you fool. That was for an interval. This is not an interval. This is a point. I repeat, this is an interval, so it gets the parentheses and the square brackets. This is a point, so it always gets parentheses. Okay, hopefully I'm sorting out any confusion. Worst case scenario, I'm creating confusion, which is not the intended goal of my lessons. Anyways, next is the y-intercept. The y-intercept is where you set x equal to 0. And for that, you're just going to say y equals the square root of 3 times 0 minus 2. That means it simplifies to y equals the square root of negative 2. And then some of you are crying right now because you got a negative square root. I'm jumping for joy. Why? Because the answer is super easy. The answer is no y-intercept. And you're done. Circle it. Easy as that. And by the way, you may be wondering, how does this make sense? It will make sense when we get to the graph. But before we get to the graph, we've got to find out if it's even or odd. Here's how we do it. Again, two-step process. First step, what's f of negative x? So that means replacing every x with a negative x, which means we have the square root of 3 times negative x minus 2. This simplifies to the square root of negative 3x minus 2, which is obviously not equal to the original 3x minus 2. So in other words, it's not even. And this is not a play on words for people who say, I can't even. No, those people are losers because they're lazy. Number 2, step 2 is we got to find negative f of x. The easiest way to do that is just put a negative sign in front of your original function. And now the real question is, does this equal the thing I said earlier? Does this equal square root of negative 3x minus 2? Let's think about this for a second. That square root, by the way, is not a distributed sign. Let me explain better. This does not equal this, square root of negative 3x plus 2. In other words, do not distribute the negative sign. That is not how this works. This is literally the most simplified you can get this. You cannot simplify anymore. Same goes for the right side. You cannot simplify that anymore either. So basically what you would say is, no, they are not equal to each other, so it's not odd either. So then what do you write if it's not even and it's not odd? You literally write neither, and you're done. Not that bad. And then the last thing we're going to do is we are going to graph this. If you do have a graphing calculator, and again, if you don't have one, just literally Google one. You'll find it on Desmos. And here's what the graph looks like. That coordinate point right there is 2/3, comma, 0. And because of that, we instantly know that the domain is, well, we already answered the domain, but the domain is every x value after 2/3. And the y values we've got here, well, the lowest is 0, and the highest, this is going up to positive infinity. So in other words, for our range, we're going to get the lowest value, which is 0, include it. You want to include the 0. And then the highest value is positive infinity, and there's our range. Any questions on domain and range? Or any part of number 4? Okay, so that's it for the first properties of functions. Now we're going to talk about the last part, horizontal and vertical asymptotes. You may wonder, how on earth am I going to finish this in 15 minutes? I have my ways. I have my ways. So the first thing I want to talk about is for asymptotes. If you remember what they look like on a graph, here's what a horizontal asymptote looks like. It literally looks like a dashed line that's horizontal. That's a horizontal asymptote. For the rest of this lesson, I'm going to be abbreviating a horizontal asymptote as HA in all caps. A vertical asymptote, I'm going to be calling a VA in all caps. And a hole in the graph, I will probably just call it a hole in the graph. Maybe I'll call it a hole. That's a little faster. So then for vertical asymptotes, what do they look like? They're just going to look like the same thing except a dashed vertical line. And then a hole in the graph, you probably already know what that looks like, but let me show you in case you forget. It literally looks like there's a little circle, like a little Cheerio in the middle of the graph. And that's what they look like. So all of them mean different things. We're going to talk about all three. So first we're going to talk about the rules of horizontal asymptotes. Again, I'm calling these HA for short. And the secret here is you're looking at the degrees. Look here, if degree of the numerator is higher, then there is no horizontal asymptotes. You would literally write no HA for no horizontal asymptote. If the degree of the denominator is higher, that means the horizontal asymptote is at y equals 0. You would literally just write y equals 0 and circle it, you're done. And if the degrees are ever equal to each other, like for instance, you have an x squared in the numerator and an x squared in the denominator, I wrote here, look at coefficients of highest degrees. I'll show you what that means in one of the next problems. So now let's look at some more example problems. Also, I was nice. I gave you the graph next to each one, so you actually know what we're talking about for the function. So the first one here, we have y equals 1 over x. And I want to find all the horizontal and vertical asymptotes. It doesn't matter which one you find first. I'll find the horizontal asymptotes first for this one. So if you think about the degree, I would say the degree of the denominator is higher. And the reason why is because, well, the degree of the numerator is 0, and the degree of the denominator is 1. Ergo, denominator is higher. What that means is instantly the answer is y equals 0. I am done. And your proof, your answer showing your work is you have to write degree of denominator is higher. If you don't write that, then you have no work. And if I was a teacher, I would just mark it wrong, even if you got the right answer. And then for vertical asymptote, this is actually, I forgot to write this. For vertical asymptotes, set denominator equal to 0 and solve. Easy as that. So here, your denominator is x. So you're just going to say x equals 0. Hold on, I'm going to scroll back up in case anyone didn't finish writing that. But for the vertical asymptote, it's x equals 0. That's it. You're done. You don't write this as a coordinate point. Why not? This is not a point. This is a line. How do I know it's a line? Look at my graph here. I'm drawing it in red. Horizontal asymptote at 0. Vertical asymptote at 0. That's why it's a line. Lines get x equals and y equals format. Any questions on that one? Okay, great. By the way, when are we talking about horizontal and vertical asymptotes? We're talking about these. They're called rational functions. Rational functions simply means there's like a fraction. There's a fraction. There's a numerator and there's a denominator. That's when we're talking about these asymptotes. Okay, next. Number 6. y equals x squared over 4x minus 4. This time I'll find the vertical asymptote first, since it doesn't matter. So all that means is I'm saying the denominator equal to 0, 4x minus 4 equals 0. You add 4 to both sides, 4x equals 4, x equals 1, and there's your vertical asymptote. As you can see on the graph, I do have a vertical asymptote at 1, so that's good. Now for the horizontal asymptote. I have to ask myself, which degree is higher? Well, the degree for the numerator is 2, because x squared, and the degree for the denominator is 1, because it's 4x. I don't even care about the minus 4. I just care about the highest degree, so the 4x. Now, anyways, since the degree of numerator is higher, that's my reason. The answer is no horizontal asymptote. Done. Any questions on number 6? Okay, and then the last one, no, there's still a few more. I'm not even close to the last one, actually. Oh, 2 left. Yeah, I guess we're close. We're definitely going to finish by the end of the hour, so that's good. Anyways, number 7, y equals negative 3x squared plus 1 over 2x squared minus 8. I'll find the horizontal asymptote first this time. As you can see, the degrees are equal, which then goes to what I was saying earlier. You got to look at the coefficients. But what the heck does that mean? Well, let me just circle the part that matters. The part that matters is the degree and the negative 3x squared and the 2x squared. Think of it like this. If I have negative 3x squared over 2x squared, and I ignore everything else, literally just ignore it, don't the x squareds cancel? The answer is yes. And you're left with negative 3 over 2. And that's our answer, negative 3 halves. That's our horizontal asymptote. Now for the vertical asymptote. Again, got to set the denominator equal to 0. This one's fun. 2 ways you can do this. I'm going to do it the easier way, in my opinion. That means adding 8 to both sides. 2x squared equals 8. Divide by 2. X squared equals 4. Take the square root, and remember it's plus or minus. So your vertical asymptotes are x equals plus or minus 2. And again, if you look at the graph, there you go. Now, one thing that's kind of interesting, you'll notice we have 2 vertical asymptotes. Can anyone think of a way that I can get 2 horizontal asymptotes? Or is it impossible? Any ideas? I will tell you, there is a way. Yeah, I don't expect you to know the answer. So, and that, by the way, it's almost like a trick question, but it is what it is. So the first way you can do it is if you have something called a piecewise function. A piecewise function is those those functions that look like this, and let's say you have like 1 over x when x is greater than 0, and you have 2x squared over x squared plus 4 when x is less than or equal to 0. In this example, you have 2 horizontal asymptotes because you have 2 different functions in your piecewise function. So that wasn't really fair of me, but this is technically one of the only ways you can have 2 horizontal asymptotes. The other way you can have 2 horizontal asymptotes is f of x equals the function arctangent of x, which you've never seen before in your life. I'm not even sure if you know where that is in your calculator, but that's the other answer. So again, it wasn't really fair, but that's a fun fact. You don't have to write this down because honestly, it's not going to show up in the homework, and it doesn't matter. And now for the last example of the night, number 8. Number 8, we have y equals x squared minus 2x over x minus 2. For the horizontal asymptote, again, you got to say who's higher, the degree of the numerator or the degree of the denominator. For that, you would say degree of the numerator is higher. So degree of numerator is higher. And so what that means is that there is no horizontal asymptote automatically. And you're done. Then for the vertical asymptote, what we're going to write is set the denominator equal to 0, x minus 2 equals 0. That means you get x equals 2, and that is the wrong answer, which is funny. How do I know that's the wrong answer? Because that should be right. Well, look at my graph. Yeah, look at that. It's not a vertical asymptote, it's a hole in the graph. Hole in the graph. And that's because, again, I set you up for failure. I love doing that. So basically what happened here is that how do you get a hole in the graph? Let me show you. Remember the original function. The original function was x squared minus 2x over x minus 2. You all made the mistake, including me, the first time I did this, of not factoring the numerator. But I thought we didn't have to factor the numerator. Yeah, well, you're wrong. It doesn't matter most of the time, but here's how you factor the numerator. It looks like we can pull an x out of both. So x times, and then you're left with x minus 2. And your denominator is still x minus 2. Ah, it looks like it cancels. When numerator cancels with, I spelled with wrong, with denominator, it means that there's no vertical asymptote, or at least at that point. You know, if there was another, let's say it was x minus 2 and then an x plus 5, well, yeah, you still got the x plus 5. That would still be a vertical asymptote because it's in the denominator. But if it cancels, then there's no vertical asymptote there. And again, the numerator normally doesn't matter at all. That's why for the rest of the problems, we didn't even, well, technically we should have looked. Let me explain. If I scroll back up to number 6, for instance, if I scroll up to number 6, I can't factor the numerator. Like, for instance, I mean, you get x equals 0, sure. But we got a vertical asymptote at 1, and the numerator did not factor at all. Or if it did, it was x equals 0. So there was no hole in the graph. Technically, you should always look for that. I mean, for number 7, I don't even know how you. I guess it's possible to factor the numerator, but you should always try because I guarantee you, I put one trick question in the homework that is going to be a hole in the graph. So please try and factor the numerator and denominator and see if any terms cancel. That's all I'm saying. Okay, so it looks like we're going to finish just on time tonight. Fantastic. If no one has any questions, you're free to go. If you do, you can stick around. Thank you all for attending, and I'll be sending out the homework after this and the recording as well. Take care, and bye-bye.